Now we're going to look at something called combinations. So what's a combination? First of all, let's take a look at a problem. Braden, Ellie, Michael, and Zach are all applying for 2 lifeguard positions at the YMCA. How many different ways can they pick lifeguards? Well, they could pick Braden and Ellie, Braden and Michael, and Braden and Zach. Or Ellie and Braden, Ellie and Michael, Ellie and Zach. Michael and Braden, Michael and Ellie, Michael and Zach. And then Zach and Braden, Zach and Ellie, and Zach and Michael. But does it really matter if I pick Braden before Ellie or Ellie before Braden? Why or why not? Well, hopefully you realize if I'm hiring for lifeguard positions, all you want is a lifeguard position. You don't care if you were hired on Thursday or Friday. All you care about is that you were hired. So no, order doesn't matter because all they care about is having the job, which means that there are actually several duplicate answers here that I need to cross out. So looking at that, there were really only 6 ways to pick them. Braden and Ellie, Braden and Michael, Ellie and Michael, Braden and Zach, Ellie and Zach, Michael and Zach. So if I had used the permutation formula, would I get the 6 ways? Well, I'm going to go ahead and put in 4 students to choose from, and I'm going to pick 2. And when I do the calculation, I get 12. So the question is, how many different ways can I order the choice of Braden and Ellie? Let's just look at that. And how does this explain the difference from the permutation formula? Why am I getting 6 and permutations is getting 12? Well, if I look at my final choice there, I'm picking, if I have 2 people to choose, how many ways can I arrange them? I can arrange them twice. So this takes out the double counting, and in some cases when there's more than 2 things, triple or quadruple counting. So I need to divide by the number of permutations by 2 to get the right answer. So we need to know the difference between permutations and combinations. Permutations is when order matters. That would be like if you have people holding office, finishers in a race, a batting lineup in baseball. It does not matter, order does not matter for combination problems. So that could be like pulling Jolly Ranchers out of a bag. Does it really matter if you get the blue raspberry before the strawberry? Not really. So in this example, first of all, I want to make sure that you can tell the difference when order matters and when it doesn't. If I'm drawing 5 cards from a deck, does it really matter if I'm going to get all 5 before I play, what order I get them in? No, not really. So I would call that a combination. If I'm picking the batting order for baseball, that very much order does matter, and there's strategies for doing your order. So we would call that, we would use permutations on that. If I'm picking officers for a club, is it different to be president than secretary or vice president than treasurer? Yes. So order matters. If I'm picking flowers for a bouquet and I have 2 roses and then 2 lilies, you would never notice which ones I got first. So order does not matter. That's a combination. And if I'm picking 2 books for a trip, I would say that's a combination because I'm not going to know, oh, did I put that one in the suitcase first or that one? Doesn't matter. All that matters is they got in the suitcase. So that's also a combination. So since order does not matter in combination problems, how can we adjust a permutation formula for combinations? Well, all we have to do is we're sometimes double counting or even more, depending on how many ways we could arrange it. So what we're going to do is divide by the number of ways we can arrange the r things we chose, or r factorial. And this gives us the formula for combinations, which looks a lot like the permutation formula, except you have that little extra bit, r factorial at the bottom. So we're going to look at an example to calculate the number of ways to pick 52 cards from a deck. First of all, always start with how many you have to choose from. We have 52 cards to choose from, so n is 52. And we're going to pick 5, so r is 5. So I basically can go ahead and put this in the formula, 52 factorial over 52 minus 5 factorial, and then I have that extra 5 factorial because I'm trying to take out the repeat counts, all right? Now, if I was really trying to figure this out and not use the calculator formula, I would just say, oh, it's 52 times 51 times 50 times 49 times 48, all over 5 times 4 times 3 times 2 times 1, or 2,598,960 ways to pull 5 cards from a deck. I bet you didn't realize there were so many. But the good news is that your calculator is willing to do the combination formula for you. So first of all, when you're doing it, you're going to press N like before. You're going to press Math like before. We're going to go to probability. The only thing new is now, instead of pressing 2 for permutations, we'll press 3 for combinations. And just like before, we're going to then hit the number for R and hit Enter. So here's the example with our 52 card deck. 52, hit Math, then go over to probability, go down to choice 3, which is combinations, and then put in the 5 cards we're choosing, hit Enter, and there's your answer. So for further reflection, what is a combination? Well, it's a number of ways to arrange or pick something. I don't want to say arrange, you got to be careful. When order doesn't matter. And how were you able to tell when you needed to use a permutation and when you needed to use a combination? How is the formula for combinations different from the formula for permutations? And what is a shortcut to enter combinations in the calculator?